LSTM is a specialized RNN architecture that has the capability to deal with long-term dependencies, which is a shortcoming in traditional recurrent neural architecture. LSTM introduces the idea of constant error flow to create constant error carousel that ensures gradients not to decay, which is important because when storing information for a long period of time, um, the error backflow gets reduced or decayed. With the constant error flow, this problem of vanishing gradient descent problem is overcome. LSTM uses a multiplicative gating mechanism rather than a single neural network layer to maintain the data flow. It comes in different variants: simple, stacked, bidirectional, and CNN are some of the variants that we explored in this project. Let's take a look at simple LSTM variant. A simple LSTM variant has one LSTM hidden layer, which connects from input layer to the dense layer that predicts output. The figure here shows that LSTM layer consists of four main gates or units, of which one is memory cell and three are logistic gates: forget, read, and write. The three logistic gates interact with the memory cell in a very specialized way. So let's take a closer look at LSTM layer to understand how the algorithm works. The key to the LSTMs is a cell state, which is a horizontal line that's running through the entire chain process. The cell state acts like a conveyor belt, um, which allows the data to flow along without any time lapses or interruptions. The information is added or removed from the cell state by gates, which are read, write, and forget. A gate is composed of a sigmoid layer with a pointwise multiplication operation. Let's see how each of the gates interact with the cell state. The first gate that interacts with the cell state is a forget gate. It decides on what information to store or delete from the cell state. Once a forget gate makes a decision, the next gate is input gate, which decides on what new information to be stored in the cell state. Uh, it, it performs by two layers, input gate layer and update gate layer. Input gate layer decides which values to update, and update gate layer decides how much the value needs to be updated by. Once we have the outputs from the forget gate and the input gate, combining those outputs would determine how much information needs to be added or deleted from the cell state carousel. And finally, the output gate runs a sigmoid layer to filter and decide on what to output from the cell state update basing on the cell state. These are the three other variants we implemented in our project along with the simple LSTM. A stacked LSTM has multiple LSTMs connected with each other, where each LSTM layer has more than one memory cell. And bidirectional LSTM has forward and backward LSTMs on side by side, but input sequences in one of the LSTMs is in a reverse direction. In one of the research paper, we studied that bidirectional LSTM has a very good performance. So we wanted to see how the performance would vary with our datasets. And finally, the CRNN LSTM has a convolutional model combined with the LSTM model, which is useful for feature extraction, like extracting textual description from an image.